Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 4, Lesson number 8 on Introduction to Logarithms. Logarithms. They have kind of a funny name. You know, you look at them, they have nothing to do with trees or logs or anything like that. And yet, they are one of the most important and one of the newest mathematical sort of additions that we have. They were invented in the last couple hundred years, which for math is that's like a baby idea almost. You know, it is brand new. Let's jump right into them and try to start understanding what's up with logarithms. All right, let's start with an exponential function. The function f of x equals 2 to the x is shown graphed on the axes below, along with its table of values. So I'm giving you the whole thing. You know, here's my function. Here it is, here's its graph, here's its table of values. Let's take a look. Letter A. Is this function one-to-one? Explain your answer. What do you think? And the answer is absolutely yes. Here, I'll even do an exclamation point. For every x, there is a unique y value. Letter B. Based on your answer from part A, what must be true about the inverse of this function? Well, what's true of inverses of one-to-one functions? They are also functions. Or I should really say it, because we're just talking about it is also a function. Right, so whatever the inverse of this is, it's also a function. Letter C says, create a table of values below for the inverse of f of x equals 2 to the x, and plot this graph on the axes given. So remember, with inverses, inputs become outputs, and outputs become inputs. So literally, that output of 1/8 becomes an input, and then the input of -3 becomes the output. Remember that, right? X goes into f of x, out comes y, y goes into f inverse, out comes x, right? So when x is 1/4, then the output must be -2. When x is 1/2, the output must be -1. When x is 1, the output must be 0. When x is 2, the output must be 1. When x is 4, the output must be 2. When x is 8, the output must be 3. So let's plot it. I know this is going to be a little bit tricky, but if I go to x equals 1/8, y equals -3, we're down there. 1/4, -2. 1/2, -1. 1, 0, 2, 1, 4, 2, 5, 6, 7, 8, 1, 2, 3. So get that. And notice this, right? Here's f inverse of x, here's f of x, and they're symmetric across that line y equals x, right? If you literally look at that as a mirror, you can tell that if you flip one of those graphs over, you'll hit the other one. All right? So there it is. There's the inverse of 2 to the x. All right? Pause the video right now and write down anything you need to. All right. Now we're going to continue with this exercise on the next sheet, but I'm going to reproduce some of this work there, okay? So there we have our inverse function, right? We have y equals 2 to the x, y equals x, all of that. I even reproduced the table of values. So, you know, we have a lot of this function. We know basically everything that there is about it, but we don't have an equation for it. We don't really have a name for it. So it said, what would the first step be to finding the inverse of this equation algebraically? What's the first step? See if you can pause the video now and think about what that first step is. Write it down and then stop. All right. Well, let me just be very clear, right? This is the original function. its inverse, the first thing we're going to do is we're going to switch x and y. Now, typically, the second step, that's step number 1. The second step is typically, step 2 is solve for y. But we don't know how to do that right now. We don't know how to solve this for y. We can't divide by 2 on both sides because we're not multiplying. We literally have x equals 2 to the y. Okay? And yet, this is amazingly important because it gives us the essence of this function, right? It really tells us that the output is whatever we have to raise 2 to get the input, right? It kind of makes sense, right? Right? I have to raise 2 to the negative 3 to get 1/8. I have to raise 2 to the negative 2 to get 1/4. Raise 2 to the negative 1 to get 1/2, etc. And that makes sense. This is literally doing the opposite of what an exponential does. An exponential takes an exponent and gives us an output. This function is sort of taking the result of an exponential and giving us the exponent we need. All right? And this is going to allow us to define a logarithm. So pause the video now, write down anything you need to, and then we'll define what a logarithm is. Okay, here we go. Let's define a logarithm. Okay, so we're going to write logarithms like this. The word log, this is going to be a base, b, same as the base of an exponential. And the logarithm is the inverse of y equals b to the x. So a logarithm is simply the inverse of the exponential with the same base. This is not me using 2 letters to mean different things. These are the exact same thing. But now think about it, right? To find the inverse of this, we would just switch x and y. So that means that log base b of x is the same as b to the y equals x. This is what's known as the equivalent exponential equation. All right. Logarithms give us the exponent, right? That's what they have. Their outputs give us the exponent we have to raise the base to in order to get the input. I think of them very similar to the way I think about roots, right? When you think about the square root of 36, well, you know it's 6, but you know that because 6 squared is 36. Logarithms are the same way, right? They're really the sort of opposite or the reverse of an exponential. We're now looking for an exponent. So let's take a look at this. Pause the video now, write down anything on that mess that you need to, and then we'll start to get a real workout with logarithms. All right, let me clear this out. Now, exercise 2 says evaluate the following logarithms. If needed, I'll show you what that means. Write an equivalent exponential equation. Do as many as possible without the use of your calculator. So in other words, what does this even mean, log base 2 of 8? Well, let me write the equivalent exponential. Let me call that x. The equivalent exponential would be 2 to the x is equal to 8, and x would be 3. All right, so in other words, the log base 2, stick in red. The log base 2 of 8 is equal to 3. Now we can keep writing these equivalent exponentials. That's not necessarily a bad idea. Okay, but I'm going to try to do it without it. So in other words, the log base 4 of 16 equals what? Now remember, what we're really trying to do is figure out what we have to raise 4 to in order to get 16. Well, that's obviously 2, right? 4 squared is 16, and therefore the log base 4 of 16 is 2. What do we have to raise this to get this? So log base 5 of 625, that might be something you have to use your calculator for. You might have to sit there and go, okay, what's 5 squared? You know, you might have to say, 5 squared is 25. And you find 5 to the 3rd is 125. 5 to the 4th is 625. Oh, that's it. So log base 5 of 625 is 4. because 5 to the 4th is 625. How about the log base 10 of 100,000? What do I have to raise 10 to get 100,000? Well, this one should be easy. 1, 2, 3, 4, 5. 10 to the 5th is 100,000. And therefore, log base 10 of 100,000 is 5. Now let's do some that are a little bit trickier. All right, negative and fractional exponents. One thing I want to emphasize, though, the output of a logarithm is an exponent. The exponent that you have to raise the base to in order to get the input, the thing you're finding the log of. All right, so take a look at this. I got to figure out, what do I raise 6 to get 1/36th? Well, obviously 1/36th is equal to 1 over 6 squared, but that's 6 to the minus 2. So the log base 6 of 1/36th is negative 2. We have to raise 6 to the negative 2 power in order to get 1/36th. This is tricky, isn't it? Very similar to square roots and squaring, logarithms, and exponentiation. Think about letter F for a minute. Log base 2 of 1/16th. What do I have to raise this to in order to get this? Right? Well, let's see. 1/16th. That's 1 divided by 2 to the 3rd? No, 2 to the 4th? Yeah. So that's 2 to the minus 4. So log base 2 of 1/16th is negative 4. How about the log base 5 of the square root of 5? Well, the square root of 5 is simply 5 to the 1/2. So the log base 5 of square root of 5 is just 1/2. Oh boy, this last one is very tricky. The log base 3 of the 5th root of 9. I got to figure out what I raised 3 to get the 5th root of 9. Well, what is 9? 9 is 3 squared, right? So the 5th root of 9 will be the 5th root of 3 squared, but that'll be 3 squared to the 1/5. So that'll be 3 to the 2/5. Right, so I would have to raise 3 to the 2/5 to get the 5th root of 9. Wow. Logarithms really require you to be comfortable with exponentials and exponents of all types, positive, negative, zero, fractional, right? And we have to be comfortable because ultimately the output of every logarithm is an exponent. All right, you'll have some time to get used to that idea, but not too much time. So pause the video now and write down anything you need to. Okay, here we go. Let's get a little workout here. All right, exercise 3. If the function y equals log base 2 of x plus 8 plus 9 was graphed in the coordinate plane, which of the following would represent its y-intercept? All right, well, see if you can figure this one out. You have everything you need. Pause the video now and play around with it. All right, well, on some modern calculators, they have log base 2. Many of them don't, but some do. Doesn't really matter. In order to find the y-intercept, as always, I'm going to set x equal to 0. So that's going to give me y equals the log base 2 of 0 plus 8 plus 9. Now, as always, with order of operations, we're going to do this first, right? And that's going to give me the log base 2 of 8 plus 9. Now, 9 is what it is. The question is, what's log base 2 of 8? And again, that's going to be the exponent I have to raise 2 to in order to get 8. Well, we know 2 to the 3rd is equal to 8. So the log base 2 of 8 is equal to 3. So that's going to be 3 plus 9, and we're going to have a y-intercept of 12. All right, simple enough. Pause the video and write down anything you need to. All right, I'm going to clear it out. Let's take a look at another one. Between which two consecutive integers must log base 3 of 40 lie? All right. Ooh. Again, pause the video here and think about this. All right. Well, ultimately, right, whatever log base 30 is, it's whatever I would have to raise 3 to in order to get 40. Well, I know 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81. I'll just do one more. 3 to the fifth is 243. Well, where does 40 lie? 40 lies somewhere in here, right? It lies between 27 and 81. So log base 3 of 40 must lie between 3 and 4. I don't know what it is, but it's got to lie between 3 and 4. All right, we're going to do one more problem. So copy down anything you need to, then we're clearing this out. All right, let's do it. So, a little bit of calculator use. Depending on the calculator you own, many calculators have only 2 logarithms. They have what's known as the common log, which is log base 10, called the common log because it may be the most common. I don't know, I think I disagree with that, but it's very common. In fact, it's so common that they won't even write it with a base. So if you ever see a logarithm with no base, it's base 10, okay? There's also one other logarithm that shows up often on a calculator, but we're going to wait for that until a further lesson. So let's do a little bit of this on the calculator and then make sure that it makes sense in terms of what we know about exponents. Let's open up the TI-84 Plus. All right. It's going to make just a small appearance here. Okay, let's find the log button. The log button is right down here. It's pretty obvious. It says log on it. Now again, that's just log base 10. You don't get log base 5 or 7 or 2 on that. It's just log base 10. So let's hit that button and let's type in 100 and hit enter. And it gives us 2. All right. Now again, let's just make sure instead of just writing all 3 down and moving on and starting to think about our weekend or whatever day of the week it is, let's make sure that makes sense, right? I mean, the common log is log base 10. So we're doing log base 10 of 100. And certainly 10 squared is 100. So that makes sense. Let's do log of 1 divided by 1,000. Log of 1 1,000th. Try that. All right, let me do it real quick on my TI-84 Plus. Log, parentheses, 1 divided by 1,000. Enter. Ah, look at that. It gives us -3. And again, this makes sense because if I take 10 and raise it to the -3, I'd get 1 divided by 10 to the third, which would be 1 divided by 1,000. Great. Let's do one more. Log of the square root of 10. Okay, try that on your calculator. All right, now I'm going to do it on mine. Log square root 10, parentheses, and it gives me 0.5. And again, 0.5 we know is 1/2, and we also know that 10 to the 1/2 is the same as the square root of 10. So that checks as well. Now again, we're going to explore the use of our calculators with logarithms quite a bit more in the future. But for right now, I'm going to put away the TI-84 Plus. Bye-bye, calculator. Pause the video now if you need to take a look at anything on this page. All right, let's clear it out and finish it up. All right, logarithms are brand new in Common Core Algebra 2, and therefore they can be a confusing topic. After you've worked with them for a few years, you feel completely and utterly comfortable with them and the rules that they play by and the way you can manipulate them, but right now they're very new. The most important things to understand about them are, number one, they are the inverse of exponential functions with the same base. So log base 2 of x is the inverse of y equals 2 to the x. Log base 10 of x, that common log, is the inverse of y equals 10 to the x. The other thing that's, of course, very, very important is simply what the function does. The function takes an input, and as the output, it tells you what you have to raise the base to get that input, which is rather confusing, I understand. Well, we'll work more with them in future lessons. For now, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.